Okay, let's dive into the fascinating, high-stakes story of the hardware that powers our entire world. For years, the engine of the AI revolution really had just one name on it. But now, a massive battle is brewing between three of the biggest companies on the planet. For the longest time, that question had a really simple answer. But today, the very chips that make AI possible have become one of the most intense battlegrounds in all of tech, and the answer is getting more complex by the day. $5 trillion. That's the mind-boggling valuation Nvidia has hit. To put that in perspective, that's more than the entire economy of most countries. They built this empire by becoming the default choice, the primary engine for pretty much all of artificial intelligence. So today, we're going to explain this brand new landscape. We're breaking down how two huge challengers, Google and Apple, are coming at the king from completely different angles, and it's creating a genuine three-way fight for the future of AI. First up, let's talk about the undisputed champion, Nvidia. If you think about the AI boom as a gold rush, then for the last decade, Nvidia has basically been the only company selling the picks and shovels. And let me tell you, business has been very, very good. Nvidia's power is built on way more than just fast silicon. I mean, a 90% market share is just staggering, sure, but it's their presence on every single major cloud platform and the deep, deep trust they've built with big companies that makes their position so incredibly hard to challenge. And this quote right here, this really illustrates their true advantage. It's not just about having the best chip, it's about their powerful software ecosystem called CUDA. It's so deeply embedded in how AI gets built that switching to a competitor, even if it's cheaper, is often just too hard and too expensive. It's like a giant software moat built around their castle. So how do you even begin to compete with a giant like that? Well, Google's not trying to build a better shovel. Instead, they've built their own highly specialized, custom-designed mining machine. They call it the Tensor Processing Unit, or TPU. And unlike a general-purpose chip, a TPU is what's known as an ASIC, an application-specific integrated circuit. That's a fancy way of saying it was designed from the ground up to do one thing and one thing only: accelerate the very specific math that makes AI work. So think of it like this. An Nvidia GPU is like a powerful, flexible Swiss Army knife. It's great for everything from gaming to scientific computing. A Google TPU, on the other hand, is a specialist. It's like a surgical scalpel, precision engineered for just one job, those tensor operations at the very heart of machine learning. And this wasn't some sudden move. I mean, look at this timeline. Google has been quietly building and perfecting this tech for over a decade. It started out secretly powering its own products, and now they're offering these massive systems with thousands of chips working together on the Google Cloud. All right, let's move to our third player, Apple, who is playing an entirely different game. They're not selling shovels or building giant mining machines. They're trying to put a perfect personal little pickaxe into the hands of every single person. See, Apple isn't fighting in the data center at all. Their M-series chips are all about edge AI, running models directly on your laptop or your tablet. And this is a huge deal. It makes AI fast, it makes it incredibly private, your data literally never leaves your device, and it's super efficient, which is crucial for battery life. Okay, so we've got the king, the specialized challenger, and the personal powerhouse. Let's see how they actually stack up across three key battlegrounds that are really going to define the future of AI hardware. First things first, we need to understand that there are two fundamental jobs in AI. It's not just one big task. There are two totally distinct halves to the whole process. So training is the heavy lift. It's teaching a model like ChatGPT on basically the entire internet. It's incredibly expensive, and it only happens once in a while. Inference, though, that's using the trained model to answer your question. That happens constantly, billions of times a day, and it needs to be as cheap and efficient as possible. And right now, the entire industry is shifting its focus from training to inference. And that massive shift to inference makes the economics of running these chips absolutely critical. When you're doing something billions of times a day, every fraction of a cent and every single watt of power matters a lot. Now, if you look at real-world cloud pricing for inference, this is where the specialization of Google's TPU really starts to pay off. For the right kind of job, you can see a really clear cost advantage. We're talking about potentially cutting your hourly compute bill in half compared to some of NVIDIA's very best chips.
And it's not just the sticker price. TPUs are designed from the ground up for power efficiency. For the exact same amount of AI work, they can use up to 40% less electricity. For data centers facing gigantic power bills and physical space limits, that is an absolute game changer.
So you might be wondering, okay, if TPUs can be cheaper and way more efficient for inference, which is the biggest part of the market, why isn't everyone just switching over right now? Well, the answer comes right back to Nvidia's ultimate weapon, CUDA. This software platform is, for all practical purposes, the language of AI development. We're talking years and years of code, libraries, and developer skills that are all built on it, creating that deep, powerful moat that makes switching to Google's ecosystem a really massive undertaking. So after looking at all of this, which chip is the best? Well, for the first time in a very long time, the most exciting answer is, it depends. The winner really depends entirely on the job you're trying to do. If you need private, portable AI on your laptop, that's Apple, hands down. If you're training a huge new model and need maximum flexibility, Nvidia is still the king. But if you're running a massive service and your main goal is to slash those inference costs, Google's TPU is now a very serious contender. You know, this quote from a hands-on technical review just sums it up perfectly. There is no magic bullet anymore. We're finally in a genuinely competitive market where your specific needs actually dictate the right tool for the job. So, for the first time in years, the future of AI hardware is no longer a monopoly, it's a high-stakes race between three very different strategies. Nvidia's dominance is still very real, but it is no longer absolute. The only question now is, who are you going to bet on to build the future?